Hello folks, well, we've got a realistic TRC1007 here. So it's an end user and he says, encloses my realistic TRC1007, had it around 30 years and as far as I'm aware it's never been opened, never mind being serviced. So he says he's got the Skiptech HS2000 and the Skiptech is receiving much clearer than the 1007. So I could barely hear anything on the 1007, whereas the Skiptech was like the person next to me. So we'll look into that. So unlike the 1001 and the 1005, these don't have range boost side panels, and so they don't have anything like the range that you get from those sets. You can see someone's had one of those clip-on rubber ducks on it, which is fair enough. My printer's printing off the service manual. My printer's printing off the sheet. We're still on the Major 3000. I must invoice him. Where's the pen gone? I've been all day doing accounts. I'm good at filling in minus figures. Can't find the pen either. Oh, it's there. So yep and yep, and that was set. Good. So I'll do that in a bit. We'll get this powered up while the printer's doing 38 pages. And I can't remember whether these are 12 volts or... It says 12 volts on there. We'll see what the service manual says, because it might be capable of doing 13.8, I don't know. So we'll run it at 12 volts for now. Boot up on channel 9, which is always not amusing, and we'll get the Motorola adapter to plug into the external aerial socket. It says 4 watts, but it isn't. It's rounded up, isn't it? So what I've said before, the car with the 1300 engine, when you actually look at it, it's 1256. So I'll put picture in picture on. I just can't write any figures down at the moment. At least we can make a start. So transmit, we're on the 3 watt scale and it's doing 2.7, something like that. So let's just put the transmit, the receive frequency into the signal generator, and let's see how awful sounding this is. And I do hope it isn't right, because if I think it is right and he's not getting good results, that's disappointing. He's only 35 miles away. I might drop it back personally at just the postage cost. Right, so that's... That's 0.3 of a microvolt. 1, 3, 10. This is deaf as a post. That's S9. Pulled the plug out as well. So what I'm doing there is seeing whether I get a different result with the telescopic Obviously there's no earth. It's inner only. Right, well, we better open it up. And tomorrow, or whenever I finish this, I want to do the second D'Amico convoy. Really put some time into that. Then they can both go back to the customer. I've got a brand new Allen 42 hand portable. It'll be either the multi or the, can't remember whether it's the multi or whether it's the DS version. Brand new in a box, so I might optimise that and sell it. I bought one too many, probably to get the price break. Okay. The most difficult thing to set up on these is the transmitted audio. You've got to manipulate two presets. So I think we'll do everything except that. Probably have to come back to that tomorrow because it's getting on quite late, but I do want to make a start on this. It's in lovely condition. A lot of these have got ingress of moisture, so you find there's corrosion in the bottom of the set. So nearly every one of them you see, all this is corroded, but this is in lovely condition. Okay, so we've got the sheet now and we can run through things. So we'll start looking at 12.5 volts, which is exactly what we're going to be running it at, and let's see, it's plus or minus 15%. Right, so 12.5 times 15%. To take up to, it'll do 13.8, it says 14.3. So that's fine. So although ideally it's going to be 12.5 volts, and the usual thing, it's going to be 10 AA's of the rechargeable variety, or it's going to be 8 and 2 dummy batteries, 4 throwaway 1.5 volt batteries. Rechargeable batteries are 1.2 volts, so 10 times 1.2 volts is 12, and conversely, throwaway batteries are 1.5 volts, so 8 times 1.5 is also 12. So if you fail to put dummy batteries in, you use throwaway battery, it's going to be above 15 volts and it will kill the radio. And we've seen this on many a handheld in the past. Right, so let's just look at, we'll put it back on and wind it back up to channel 20 with its pretend rotary switch, which is really an up-down. And it's 2 point, I'll tell you what, we'll go to 13.8 now we've told that. That's different. 3.2 watts. I'll see what it's supposed to be in a moment. Channel 40 is 3.1 watts. And channel 1, 3.2 watts. Low power is 102. We'll call it 200 milliwatts. And the transmit current on, well, that was a failed test, wasn't it? Because we should have been on channel 20. Still the same. It's 842 milliamps. Deviation, for what it's worth on this test set, wallow, it's 0.9. I can believe that as well. These are very funny AGC. Banatone Route 66 have very funny AGC, and one or two others where the peak actually over deviates as you speak, and then it settles down. These are another set that does that. It's not a big problem, but it's just different. Transmit frequency. Let's have a look. Put the different camera on, and we've got 2779108. So it's nearly spot on. And here we come to receive. So we'll plug the test gear into the earphone socket. It's going to be there somewhere. There it is. Yeah, it's not good at all. 7.5 microvolts for 10 dB. 7 for 20. It does do 20 for 30 microvolts. Squelch. 100 microvolts. Just where I like it. And minimum squelch. That'll be interesting. Is 1.4 microvolts. Actually, oh no, I'm misreading this. 4.5. So it doesn't have an RF meter, doesn't have an S meter, doesn't have a meter lamp. They work, those work, that works, doesn't have that, that works, and that works. I've managed to clip the lead into the clipboard. Okay. See if we can get to the bottom of its ailments. So although it's not struggling with transmit, we'll do that first. And it says the power output, let's have a look. It says, I will turn the volume down so as not to annoy people. It's supposed to be 3.5 watt, and it's supposed to be between 3 with absolute maximum of 4. They want low power to be 0.25, yet it's supposed to be 0.4, but I don't know where they got that figure from. But anyway, I don't think anything's adjustable apart from deviation with those two and whatever's there. That power. Very, very good service manuals as ever. If you want to learn about repairing things, buy the realistic service manuals just to read them. 3 variable resistors. We're not going to do the phase lock loop alignment. The guys owned it from new. There's no reason to. We have a different tariff of fees if we start going through everything. So there's no point in. I have covered these sets many a time before, but what we do need to do is to pop it onto frequency. I'll just turn it off a moment. We'll go in the can. And it is. They want you to do with the frequency counter on test point 5. We're not doing that. We don't need to do it that way. So, and then you adjust what? TC1. And TC1 is somewhere down there. So here's the conundrum. We're going to have to turn the channel selector till the thingy comes through, aren't we, the signal. The 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So going to transmit. Are we on the frequency counter? No, we're not. And my trimming tool is on the ceramic floor. I think we're going to take the rod aerial out so we get some real figures as well. This is fun to adjust. 126. Right, I'll quickly put that. I'll put the screen cam back as well. I didn't realise I didn't have to take that off. I don't think there's anything in there we're going to need to adjust, because I'd expect it to be VCO, but we better just look, because we've got T7 and T8 in there. Yeah, we do need to adjust T7 and T8. So it's L3, T7, T8. So let's look at this. So we know that's T7, T8. So we've got L3, T7, T8, T9, L5 and L6. L5 and L6. Start here. Is there a preset for power level? Oh right, yeah. So just make sure the low power switch is in high. So the variable resistor is the power. So we need to set that to full first. Let's put this back as a temporary measure. I'm going to take the rod antenna out because, as we've seen before, it drags. Let's turn it off. I'll put the screw in the end of that before we lose it. Now we're going to get some much truer readings. With the power at 13.8 volts, we're getting just above 4 watts. I've got to be very quick, I don't want to damage the set. It shouldn't be running at this kind of power. Hello, we're on a lower power suddenly. Is there a dry joint? Something slightly out of kilter here, so let's hope we can fix it. So that's in the centre. That's in the centre. I'm happy with those. We're supposed to adjust this one first, aren't we? That's correct. That's correct. And then we'll drop this to 4. And then hopefully at 12 volts, 12.5 volts, put that shield plate back on. With it's not always transmitting properly. It could be that, or it could be a malfunction. Now it's warming up. it's transmitting on channel 9. It's transmitting 3.2 watts on there. Let's go back to 13.8 volts. Fine. So I want it to be I actually want it to be, go back to channel 20. I actually want it to be 3.5 watts. Yeah. I'm going to go through these again now we've got the lid on. Go back to 13.8 volts. Good. So now when we go to 12.8 volts, it's doing 3.4. Excellent. Can't quite fry your dinner on there. So we're going to come back to deviation because it's exceptionally complex. I'm going to have to look round this for dry joints because the receiver is now how we'd expect it to be. But that could be because I've taken the aerial off. So onto let's do the detector first if it's got one. Yeah, transformer 4. So transformer 4 is that one there. So it's that one there. So that's the camera remote on the floor. So with a 100 microvolt signal on, the oscilloscope on, we'll switch to the appropriate camera. Enough volume for a sensible trace. That was about right. Over to the cyanide meter. So L3, 7 and 8, let's turn that down a little bit. L3, 7, L3, T7, 8, 9. L3, T7, hang on a minute, let's transmit it, what am I doing? T4, T1, 2, 3 and 6. So we've done T4, T1, 2, 3, 6. No, it's that 6. T1, T2, T3, T6. So 1, 2, 3, 6. Drop the signal. the biggest signal on for that one. Smaller signal. About there. So right now, for 12 dB, we've got 1 microvolt. It's not outstanding, is it? What does the manual say? No, it's well within. It says for 10 dB, the limit spec's 1 microvolt. So for 10 dB, we've got 0.84 microvolts. I'm just going to go through it again, just in case we can gain something. Got the biggest signal on for that one. Out there. Yeah, it's 1 microvolt for 12 dB. For 10 dB, it's actually 0.91. And for 20 dB, it's 3. So will these figures revert to this when I put the rod antenna back in? The answer is probably. Right, squelch to full. So now it's 9.5 with the maximum squelch, which is what you'd expect on a walkie-talkie. Pretty weak if it was a mobile, so that wouldn't be good enough, but as a hand portable, that's fine. So now we'll do the opposite, and we'll put it on threshold. .3, which is excellent. So we've got this deviation to deal with, and I'm going to deal with that tomorrow. The other test set's not on. It's well beyond 8 o'clock, a time I wasn't working, so I'll see you tomorrow. Okay, so we've just got the fun bit of this to do, and I will look for dry joints. The deviation. It is a slide and a half to do, and to help us this time, I've printed out some supplementary bits from the service manual. So if we look at what they've got to say, back to the transmitter alignment. So pre-adjust VR2 for 2.5 volts at test point 6. So VR2 with the 2 variable resistors here. So let's see which one they are talking about. So VR2 is the one to the right, and VR1 is therefore the one to the left. Pre-adjust it for 2.5 volts. Well, test point 6 is here on the circuit. So it's a junction of resistor 79 and resistor 60 and one end of the FET and that electrolytic capacitor, and it's shown on the layout as being there, which is the lower side of resistor 79. So let's just look at that. Yes, so the lower side of 79 is there. So we've got the chip and 1, 2, it's the third resistor there. Will this be the first time in 35 plus years that I find it easy? Right, we're going to need the power on just like that. Going to want to select a sensible channel like that, and let's just see whether that heatsink is yes, so we've got 13.8 volts on the heatsink. So back to this IC. It's this IC, isn't it, here? So move that, and we can see the IC, which is LM358, resistor 76, 77 and 79. So presumably we have to scrape a bit of insulation off. Hopefully we've done that, and we should now be able to get 2.5 volts. I bet that's just in transmitter. I'm going to go to low power so we're not thrashing the transmitter. Make sure we're in transmit on the test set. It might have been easier if I plugged in an external mic. So it's unaffected as to whether you press transmit or not. We've got 2.7 volts there, which is jolly good. So if we adjust VR2 for 2.5, that'll do me. And then we can do the deviation. And it says, go back to the service manual, they want it to be 1.8. Well, of course we don't. We want it to be 2.2. Oh, you adjust VR1 for 1 kHz deviation, and then you go back to 2 to get the deviation required. So let's be clear on that. We adjust VR2 for 2.5 volts at test point 6, which we've just done. We then adjust VR1 for 1 kHz deviation, and then we go and mess about with VR2 again for the 1.8 they want. This is going to be fun. think the best thing here to do is to plug in the external mic. I think we've got one lurking. Or did I put it back? That'd be silly if I'd put it away. Hey, that's a genuine realistic mic. Don't see many of those. Wanted to get that a final look at that Deviation Mark V green CPT set. I want to look at the second D'Amico Convoy. I've also got a brand new President Barry, which is surplus, so I just want to service that and sell it. So, in fact, I think we're going to get rid of all the President sets because I hate them. Right, let's go back to... I've now got the external mic in. We'll do the deviation so I can actually see it. See what it says. Voila, it's about 1.5. So they want it turning to 1. That's 1. Then they want adjusting to they wanted to 1.8, but I want it to be 2.2. So I've got 2.2. Have I when I go to internal mic? Now this is going to be fun. Oh, the mic actually is there, isn't it? So I'll be able to turn around with it, hopefully. Yeah, spot on. Good. So I'm just going to go through this for dry joints now. Out of interest, just go back to the main meter on here. We'll just see what the deviation says on this test set, which is probably lying. Why are we not getting anything? Because we're not plugged into this test set, that's why. I've got my dinner cooking, so if you hear saucepans boiling over, you know why. A strange way of doing it, and they do sound funny, these sets. So as far as we're done with this set, but I need to just check for dry joints. Voila! Yeah, it's a bit lower on this one, but I think it's lying like it does. So I'll probably put it on our video microscope. Now I'll tell you what we'll do. There is corrosion up there. So I will deal with that off camera. It's gone in through the... looks like it's gone in through the external speaker socket. Now there's nothing up there. I mean, it's the phase lock loop, isn't it, up there? So it would not be working at all if that was phase. But I will just clean that up with isopropyl alcohol. But I must say this is the best condition one I've seen for years. It's not the radios, it's the people who take them out in the rain. Was that a cue to a song and I'll never have that recipe again? Sang Donna Summer, amongst others. So what we're going to do, we'll just put the signal generator on back on the correct frequency, because we're on a different day, so I'll need to reset that. I don't think you got the crystal filters on these that you'd had on the Realistic 1001 and 1005. And they were cheaper, they were £99.95, not £139.95 like the Realistic 1005 had been. So let's just see what the sensitivity is, because we know what it was yesterday. Well, it was 1 microvolt yesterday. Today it's not quite. But it's not stupidly different. So what I was getting at is, what I want to do is to put the rod antenna back and see whether that's what's robbing the sensitivity. Because when I initially tested it, the sensitivity was very different to how it ended up. So we'll do that. We'll do it with the set on, and I'll tell you what, we'll set the signal generator. I can't be putting my fingers on things, but I'll set it so that it's 1 microvolt on the... I'll start again. I'll set it so it's 12 dB on the synod meter. And then it's easy to gauge. So we'll set the signal generator till we get 12, which without me touching anything, as it stands, is 1.8 microvolts. Now, let's put this in. Without dropping the screw in the works with it on. So, can you see how the signal's now been robbed? It's now 4 point something. It's not there, it's not as bad as it was. So, I am going to just check for dry joints. I'm going to deal with that. And we'll put it together and get some final figures. So hopefully all we need to do is put it back together. So I've been over this bit of the board where it's had the water ingress. I've been over round the receiver. So all we need to do is hopefully screw it together. Right, we'll put those away. I'm sure I've got a 1007 somewhere, and if I have, I'll get it serviced and sold, because I've by that I mean a surplus one. I bought 6 at the time, and I don't need 6. I only need 1. Okay, so we've got a shorter screw and a longer screw. And a shorter screw on the floor. As a courtesy, I'll just run over these contacts, but I'm not testing it on batteries. We'd only test it on batteries if we were specifically requested to do so. Right, plug it back in, switch it on, and of course it comes on channel 9. I'll use our extension mic. I will do a final sensitivity check because it's going to be pretty dire with the rod antenna being back in. And remember, these adapters are slightly lossy. It's not like we're going in at BNC. About 4 microvolts in with the, well, it is at the moment. If I hold the earth, it isn't. Yeah, it's about 4 microvolts. But we know the set is doing 1 microvolt for 12 dB when it's not got that connected. So don't think it will be 4 microvolts, which is better than 7.5, which is when it came in. When it's connected to the aerial socket, it may be with the test instruments, but in reality when you put it on the aerial, I don't think we're going to have any problems whatsoever. Now, he has had problems. Some of that could be being very slightly off frequency, because we now got that right, and it was at 1.5 kilohertz. It's now 2.2 to 2.5 kilohertz. So we'll just check the power. Now it's back together. We're at 13.8. And what have we got? .5. .2 and 3.2. Low power. Go to channel 20. .250 milliwatts. Back to full power, and the current consumption is now 933. And there we have it. We're done. So I'll just plug it into the aerial instead. I'm not going to turn the test gear off because I'd like to get on with the swine of a D'Amico convoy. I really need some good time on that, but as ever, we're in half-hour bits and pieces. Right, dodgy activity out there. I'll use the external mic. We'll do the on the air test like that. Just make sure it's working on its internal speaker, which it is. It's nice to see one with all the covers intact. Well, as ever, nothing. Right, we'll do an on-the-air test with that, and we'll see how that works under those conditions. So I think next we're going to finish off the other D'Amico convoy, see whether we can get to the bottom of that one. Thanks for watching the realistic TRC1007 from about... oh, I've got the exact date, haven't I? It's from 1988.